The Metropolitan Woronora Special Protected Areas are on the lands of Dharawal, Yuin, Wodi Wodi and Gundungurra people. These lands always were and always will be Aboriginal land. Power pays respects to elders past and present and extends respect to Aboriginal people here tonight for this, the third talk in our POWATalks Autumn series. We recognise the ongoing connection, custodianship and self-determination of Aboriginal peoples over the water capturing ecosystems that we all rely on. And we're proud to stand with Aboriginal communities and organisations who have been active in speaking out about how mining is destroying sacred sites and damaging the ability for communities to practice and pass on culture. Particularly tonight, I think as we address the topic of sustainable water infrastructure this evening, Power reaffirms our commitment in our humble ways in this campaign to centre Aboriginal communities at the heart of decision-making about land and water management. In Power, you find everyday people organising to protect the water capturing ecosystems that we all rely on. We meet fortnightly and our meetings are open to anyone. And at the moment, we're still meeting online. So if that's something that interests any of you, please message us after the meeting and we can let you know when we're next meeting. It has been a really big time for water drinkers in the Illawarra in the last couple of weeks, as many of you will know. And I just have three quick updates for you before we pass the mic to Stu. Because we now know the full details of what South 32 wants to do with the Dendrobium expansion. The Minister for Planning is currently deciding on whether or not to approve this mine expansion. And so to recap, we defeated the proposal in the Independent Planning Commission over a year ago. We and many of you collectively sent in 930 responses, complaints about the proposal, and the IPC weighed the scientific evidence and decided to reject the expansion plan. But as we also know, the state government is desperate to see Dendrobium ushered through at any cost. And so they've designated it state significant infrastructure to circumvent the IPC's decision. And this is really, as I know many of you already know, it's just such a stunning decision to divert normal government process, which is already stacked in favour of mining companies' interests. But it's worth emphasising that we have forced South 32 to wind back their original plan considerably. The environmental impact statement, however, that we've seen in the last couple of weeks, now that it's released publicly, it's still very, very bad. And we still think we have a really good chance of stopping it. So we're inviting you to do three things. The first thing is to come and get the scoop on what's in the environmental impact statement and discuss how to write a submission. And that's in a webinar that we're co-hosting with Lock the Gate on the 1st of June at 7 p.m. I'm going to post a link to that shortly in the chat for you to register. The second thing is to come and protest with us. As you know, this is not a normal IPC process. It is entirely a politically motivated process, this state significant infrastructure decision. And so we think protesting and showing huge community opposition is really important. It's crucially important at this stage. Protesting will also get the issue in the media. And that's, it's really important at this time when people are thinking about our future and, in the context of the federal election, thinking about climate change. So we think protesting right now is very important. And we hope you can join us on Friday, June 3rd in the morning down in Crown Street outside the Department of Planning. And the third thing is to write a submission before the 14th of June. And I'll put a link for both of these two last things in the chat shortly. So they're my quick updates. And I think these calls to action are a really good background to and a true way to introduce Dr. Stuart Kahn, because many of us in Power came across Stu's work through his submission to the Independent Planning Commission's hearing on the Dendrobium expansion. It was such an impressive submission, and ever since we've looked to his work and Twitter feed for better insights into what's at stake for our water catchment, particularly as communities in the Illawarra and Sydney are fighting mining leases and expansions in the water catchment. Stu has a passion for applying science, and that's what led him to his career in engineering. He is now Professor of Civil and Environmental Engineering at UNSW. You may have recently seen him in the media. He's been making a very important contribution to public understanding of flood and drought resilience. And for all these reasons and more that I won't say tonight, we're very glad that Stu accepted our invitation to come and share his knowledge with all of us. We invited Stu to present on the question, what would sustainable water infrastructure look like? And we expect that his response is going to draw quite a few questions from many of you. So I'll ask you to stay muted for the presentation, but if you've got burning questions, you can write them into the chat or just take a note and I'll let you raise those questions at the end of Stu's talk. He's going to speak for about half an hour, which will leave us with good time to have a nice discussion together and ask Stu lots of questions about our local area. All right, Stu, so a very warm welcome to you and I'll let you share your slides.
Thanks, Rachel. So, yeah, I'll just bring them up. So, yeah, thank you to you, Rachel, and to Power for inviting me to come and speak. It is definitely a topic I am very passionate about and do spend a lot of time thinking about and talking about. So, yeah, I guess just to make clear that I'm not talking really very much at all about the current mining activities or the critical infrastructure proposal that is going on. However, hopefully it'll be clear how some of these things are inconsistent with some of the ways that we think about good management of water supplies. So I'm going to talk much more generally in terms of answering this question, what does a sustainable water supply look like? And really try and focus on what I think are some of the characteristics as opposed to, what particular pieces of infrastructure should we be building. It's more about what should we be looking for when we're deciding what infrastructure we're building with a focus on Sydney, but also a little bit broader than that as well. So traditionally, when we ask that question, sustainable, we think about what does sustainable mean. Sustainable, one interpretation of sustainable means something that you can sustain over a long term. You can keep doing it. It'll last a long time without without either being exhausted or running into major problems along the way. And some of what I'll talk about really is that sort of conventional thought of sustainability, and we think about carbon emissions and things are all related to sustainability. But I also talk a little bit about resilience and how resilience is really part of that equation for something to be sustainable, to be something that we can reliably operate and produce water from over a long period. If we're going into a period of climate change where we know that we will see increasing frequencies and severities of extreme weather events, then we need to think about infrastructure that can sustain, that can continue to operate under those sorts of conditions as well. So I'll kind of talk to both of those concepts, sustainability and resilience. So traditionally, when we think about a sustainable water supply, it's a water supply that won't run out. It's a water supply that we can continue to provide water from. So we would look at something like this. This is average inflows into Sydney's storages, Warragamba Dam and the southern dams and all of the storages. And we know that dams are there to store water from wet periods over to dry periods. So we can buffer the amount, the availability of that water through dams and through various assumptions, calculations, benchmarks. We can get a sense of how much water do we think we can reliably supply to Sydney each year through those inflows. And certainly there are some very wet years. You often don't get to capture this water because the dams are all spilling up here. There's probably a lot that we could talk about looking at this particular chart in terms of the green line being a longer term average, the red line being a more recent average. There might be evidence of climate change there, or there might be longer term periodical variability. But either way, if we want to think about how much can we reliably supply, we need to think about how do we get through these low years and buffer them with the years with more rainfall. And the current assumptions, the current calculations lead us to Sydney having a reliable supply of about 515 to 540 billion litres per year. And if we look at the current demand, it's slightly more than that. It's around 550 gigalitres per year. So we're already sitting at a point where we need to be thinking about, do we have enough water security in Sydney to get us through the dry periods? And if we look at historical demand for Sydney, this is population growth, the red line here over time. Prior to the millennium drought, we were actually using more water than we're using now, despite this population growth. And that's because during the millennium drought, we started to implement a lot of water efficiency measures. So things like dual flush toilets and low flow shower heads, things that came with a lot of the new developments that have been built since that time have been built under the basics scheme in New South Wales, which builds in a degree of water efficiency. So what we found is that during the millennium drought, when we found efficiency opportunities, after the millennium drought finished and the water restrictions finished, people didn't suddenly rip out their dual flush toilets and their low flow shower heads. A lot of that efficiency was actually maintained, and it's slowly increasing now, more or less in line with population growth. So we need to think about the fact that we probably already need to be planning for future water supplies. And that problem is, of course, going to increase over time as demand increases. So that's the way that we normally think about reliability of a water storage or water supply. However, the drought of 2017 to 2020 was a real wake-up call and made people start thinking about this in a little bit more detail. We had a plan. We had the Metropolitan Water Plan in Sydney, which tells us that as water storages start to drop, you bring in new measures. You turn on the desalination plant, you implement water restrictions. The water restrictions get increasingly stringent. Eventually, you build the next stage of Sydney's desalination plant. So we can supply 250 megalitres per day from that plant, but we can expand that plant to 500 megalitres per day. And then further down, when supplies really get low, that's when we start to say, well, now we build the next piece of infrastructure, but it was never clear what that next piece of infrastructure was. What we saw during the recent 2017 to 2020 drought, if you compare that to the millennium drought, which had previously been Sydney's worst drought on record, we saw that we could go from more or less full dams to 50% capacity. It took us about 4 years, but this drought, we went twice as quickly. There were fewer replenishment events, and the demand on that water stayed quite solid throughout that period. And that was a big wake-up call to the New South Wales government, to Sydney Water, basically telling them, you can't build your way out of this drought. There is no infrastructure, no new infrastructure that you can build now that is going to be able to arrest this decline if it continues. If this drought continued for another year or two, Sydney would have been in big trouble, and there's not a huge amount that we could have done about it in terms of being able to respond in that period of time. So we were very lucky that that drought broke. So that brings us to thinking quite differently about a resilient water supply, and it made the New South Wales government start to think about this new term that turned up in it's currently just the draft Greater Sydney Water Strategy. We don't have the final version of it yet. And I think the subtitle here is really important: Water for a Resilient Sydney. So how are we going to get through these extreme climate events? And that's when you see this new term being introduced. Didn't see it in the previous Metropolitan Water Plan. And it's more than a term, it's really a benchmark. So rainfall independent water supplies. So now we're thinking about, okay, we need to have a particular reliable yield that we can produce water from year after year. But not only that, we need to be able to get through these extreme droughts. And the way that it has been identified that we can increase resilience to those extreme droughts is to have some water in our system that is not dependent on rainfall. If it doesn't rain, the water is still there. And so we started to see this benchmarking going on, where here is Sydney, percentage of water, the percentage of our total demand which can be supplied from rainfall independent supplies. Some of it comes from the Seawater desalination plant, about 15% of our water use, and some of it comes from various types of recycled water. And as you can see, just starting to compare to cities like Melbourne, Perth and Adelaide, Sydney has a very low proportion of rainfall independent supply. So that means we're much more vulnerable to a lack of rainfall, to drought, than some of these other cities might be. So thinking about how we've built in rainfall independent supply in Australia, most of our big cities now do have seawater desalination. It has been the first port of call. Seawater desalination is an engineering solution that often we end up with if you've run out of time to do anything else. So it's often, it has the advantage that there's no competition for that water. Some sort of public acceptance issues, but generally they're considered to be minor compared to public acceptance issues around things like purified recycled water, for example. So we see seawater desalination plants around the country that now are capable of supplying between 15 and 40% of the local drinking water supply, and Sydney being at the bottom of that range. So in terms of sustainability, one of the big issues that comes up around seawater desalination is the amount of energy that's required to produce drinking water from saline water, seawater at 35 grams per litre salt. And that was a really big issue when Sydney's desal plant was being constructed, and it was a big issue for all of these plants. And I think that this is worth noting, how that has been dealt with to some degree. In the planning approval, which is what this document is, the planning approval for Sydney's desalination plant, there was a requirement written into it that the energy that would be used by the plant, which is really a significant amount of energy relative to the energy use in Sydney or New South Wales, that energy would need to be offset by purchasing green power. And so for that reason, Sydney Water, or the Sydney desalination plant, purchases green energy from a wind farm. It's the one down at Bungendore, which is the one that Joe Hockey said was an eyesore that he doesn't like looking at. But there's a couple of really interesting things that came from that. To my mind, it really kickstarted and enabled the start of a wind energy supply in Sydney. It's a little bit like when you think about the big shopping centres, and the shopping centres need their big anchor customers, the Coles and the Woolworths, before it can be viable for Joe's bookshop or the smaller customers. It was this big anchor customer, the Sydney desal plant, that really made that wind farm a viable option, and therefore made a real contribution to the availability of renewable energy in Sydney. And that was a trend that was followed by all of the desalination plants at the time in Sydney. And this is not something you see in other countries. This is really an unique Australian thing, where all of those desal plants were approved with requirements to offset their energy, which of course comes from the grid, and it's a coal-fired grid, but the amount of energy that's being used from that grid is being replaced with green power, and that was across the board at the time. There's been a little bit of backsliding on that, but not a lot. So that's one form of rainfall independent water supplies. Some other cities, some that are inland, for example, that don't have access to seawater, like Orange, have come up with other solutions. In Orange, they find that during a drought, when it rains during a drought, the soils don't generate a lot of runoff. Our catchments don't generate runoff because the soils are dry and they act like a sponge, and they soak up the rainfall that lands on them, so it doesn't run off into our dams. In Orange, they found that they built this scheme, which is an urban stormwater harvesting scheme. There's a creek that runs through Orange, the East Orange Creek. In fact, this is really just stormwater drains. This part's more of an open creek. And that creek continues to run during droughts every time it rains. And that's because the water that's in that creek is not landing on soil, dry soil. It's landing on impervious surfaces, footpaths, roads, roofs of houses, which then runs down and fills this creek. So the creek runs even when the drinking water catchment, the regular catchment, produces no runoff. So Orange built a scheme at the end of the Millennium Drought where they capture the water from that creek, the urban stormwater, they store it, they treat it, and then they pump it into their drinking water supply reservoir, Suma Park Dam. And if you look at the next slide here, this is an example. This is now the ex-mayor of Orange, Reg Kidd, talking about how during the most recent drought that we had, November 2019, he's saying that we had a few small rain events in the last few weeks. They didn't produce any runoff into our normal catchment, Suma Park Dam, but the stormwater harvesting scheme did. So it's a way to build in that resilience. You wouldn't call it rainfall independent, because obviously it depends on rainfall, but it's really much more drought resistant. It's much less reliant on heavy rainfall than conventional catchments are. Here's another picture. I took this one off Twitter, that this lady here, Manu Saunders, was getting on an aeroplane in Armidale, and she took this photo out the window, and it says, Armidale, where the only green spot on the landscape is the sewage treatment plant. And you can really see it. It's very, very dry around here, but you've got this lovely green patch here, which is all being irrigated from water from the sewage treatment plant. So the sewage treatment plant is a very reliable source of water. Even during droughts, people tend to flush the toilet and have showers and do all of those things. So we can learn from that, and we can think about the rainfall independent or the rainfall resilient supply that comes from wastewater treatment plants. And there are lots and lots of towns and cities around Australia that have started to make good use of that water from wastewater treatment plants, irrigating local sports fields, for example, and therefore being able to maintain those important community assets during drought and periods where there might normally be stringent water restrictions. So it's a resilient supply. If you use that water for a use that you would have otherwise used drinking water for, then it ultimately adds to your drinking water, because you're taking an equivalent load off the drinking water supply. Furthermore, if you use it for a use that you would have applied water restrictions during a drought, then you still can potentially have that. If you use it for a use that you would have applied water restrictions, in that case, you don't get that extra benefit, right? Because you're not going to be restricting that water, because there's no advantage from restricting that water during a drought. So if you were using it for something that you wouldn't have water restrictions for, then you still get the advantage of water restrictions elsewhere. So this has been a very reliable thing to do, a very successful thing to do for towns and cities around Australia for the last 30 years, recycling treated effluent for various irrigation purposes. But irrigation is seasonal. You can't get the local sports field or golf course to take your treated effluent when it's been raining heavily and the greens are already boggy. So you can't make optimum use of that water unless you've got very, very large storage to be able to carry the water over from a wet period to a dry period. And most local government areas don't have that type of storage availability. There are some exceptions, but generally it means that you're only using a small fraction of the total wastewater that you could potentially be getting benefit from. So that's why we've seen cities like Perth, for example, start to say, well, let's use the storage and distribution infrastructure that we already have for our drinking water supplies. Perth has been drawing down on their groundwater for decades, and they've started to say, well, we could take our treated effluent from a wastewater treatment plant, invest the money and the energy in purifying that water so that water is of a sufficiently high grade that we can now recharge our groundwater system that we use as a drinking water supply. So they pump the water underground into the groundwater supply, and then that becomes part of the drinking water supply. So they are reusing that water now, but without having to think about segregated uses and seasonal uses. It's stored and it's ready to be used in the same way that the rest of the drinking water supply is used in Perth. We've seen other purified recycled water schemes being constructed, but haven't always been as widely adopted for use. So in Queensland, in southeast Queensland, supplying Brisbane, the main drinking water supply is Wagga Dam. It's been in the news in the last few days because it's flooding up there, and it's flooded the last few big events that we've had. But there is a scheme that's constructed for when it's not flooding, when it's getting closer to being empty, that they can take purified recycled water from a series of wastewater treatment plants, treat it by advanced water treatment processes, and they can use that to top up Ivanhoe Dam. So they don't need an extra storage. They use the one that they have, and then that water mixes with all of the regular surface water in that dam and is treated at the water filtration plant and distributed to customers. They built this scheme at the end of the Millennium Drought. The Millennium Drought said we need some way of keeping water in Ivanhoe Dam. That drought, like the more recent drought, was broken by flooding rains. And more or less since the Millennium Drought, they haven't had the water supply shortage in that dam where they've actually needed to use this scheme. And they can't use this scheme when it's flooding, when the dam's full, because they're relying on some space in that dam, which they don't currently have. So this scheme is fully constructed and could be recommissioned and up and running, but it hasn't operated. It's supplying a small amount of water to power stations and things like that, but it hasn't operated in terms of putting water into the drinking water supply. Therefore, they're not making full use of that potentially rainfall independent supply in southeast Queensland at the moment. There are other ways of looking at purified recycled water as well. We use purified recycled water in Sydney. Sydney has a scheme sometimes referred to as the Replacement Flows Scheme or the St Mary's Advanced Water Treatment Plant, which takes water from 3 big wastewater treatment plants in Sydney, Penrith, St Mary's and Quakers Hill, purifies that water by the same sorts of treatment processes. This is a reverse osmosis system here, and then puts that water into the Hawkesbury-Nepean River. The Nepean River at this point flows downstream, and a little bit downstream is the North Richmond water filtration plant, which is a drinking water supply for parts of northwest Sydney around Windsor and Richmond. So there are lots of examples of ways that we make use of what is ultimately a rainfall independent supply as part of our drinking water supply. So how do we start to think about choosing between these different options? And there are lots of questions that I can't go into in half an hour. But one of the things that we would be interested in, if we're talking about sustainability, is energy. How much energy is used to supply water through these different treatment processes? We had this hypothetical study done a couple of years ago. We got a big engineering company, GHD, to look at the design of a scheme the same way they'd look at any other design for a scheme, but this one was completely made up. It's not a real city, and we wanted to compare some of the different options and look at the costs, look at the energy, look at the materials used, look at the greenhouse emissions with some of the different options. I won't be able to go into all of those details, but in this city, so you have the ocean over here. Here's a dam. So you could think of this as Warragamba Dam up in the catchment. The water flows down to a water treatment plant. You could think of that as Prospect. So we have our potable water suppliers supplying water to customers, distributed areas, more dense areas, parts of the city. They'll produce wastewater, which might be used for recycling in this case. So here we have a recycling scheme, which is for non-drinking purposes. And I'll talk about this one. So this is like a purple pipe dual reticulation scheme where recycled water might be sent back to houses just for select purposes like flushing toilets and watering gardens, but hasn't been treated to the degree that's necessary for drinking. Or we could think about having advanced water treatment processes. So IPR here stands for indirect potable reuse. We could purify that water so that it is safe for drinking, and we could pump that water all the way back up into this dam up here. So this is a key feature that I'll talk about, this distance that we would have to pump, the distance and the elevation to pump up into that dam. Or another concept that's increasingly of interest in the US in particular is called direct potable reuse, where you might take that same purified recycled water, but instead of pumping it all the way up to the dam, you might put it into a supply reservoir a little bit closer and a little bit lower down. So there's less pumping energy involved in that case. Or you could do seawater desalination. So you're taking water from the ocean, from a desal plant. Different ways that different cities do that. You could pump it up to the dam In this case, the water is assumed to go into a supply reservoir somewhere, a little bit like Sydney's does, straight into the distribution system in Sydney's case. So you could design this any way you want, right? You could make these things higher, lower, further, closer, and probably come up with any answers that you want. So the absolute answers don't mean anything, but they help us to look through what are the factors that lead to a high energy use or a high cost or a high carbon footprint. So with this example, what you see, this is seawater desalination. We're looking at energy here. So the amount of energy that's required relative to the volume of water that's produced. And we see that we have a lot of energy that's required for the desalination plant, all in production. It's the treatment process is very energy intensive for seawater desalination. The blue bit here is pumping it back to where it needs to go. And in this case, we're assuming we don't need to pump it very far, a bit like Sydney. Sydney's desal plant the water comes under Botany Bay and then into the distribution system in Erskineville, behind the Erskineville Bowling Club there. It's not a huge distance, so you only have a little bit of extra energy that's required to do that. If you look at indirect potable reuse, treating wastewater is actually more energy efficient, requires less energy than treating salt water from the sea. So we have a lower energy footprint for the treatment, but we have to pump it all the way up to the dam in this case, a high elevation and a long distance. So we actually end up with roughly the same amount of energy requirement in this example as what was used to treat it. If you go to direct potable reuse, you still have to purify the water. So it's the same as indirect potable reuse, but you're pumping at less distance because you're not going all the way up to the storage. You might just go somewhere into the supply system. And then here you have this dual pipe system where you're not investing so much energy in treating the water. It's not suitable for drinking. And you're using it locally. You're just pumping it back to houses. So lower level of treatment, local use, a much lower energy footprint in this case. So there's some of the considerations that we would think about. But then when you look at this chart, if things start to get turned on their head, we've got all of these costs and benefits coming from different directions. So here we have the materials that are used to build this purple pipe scheme. We have to build a whole new storage, pumping, new pipes, a separate pipe to each house to send the water back. So we have very high materials investment in that. And all of that has a carbon footprint as well. If these are steel or even PVC pipes and the pumps that are required, all of that has energy embedded in the materials, not just the actual pumping energy that's required. So things start to fall out in a different order. So I'm not trying to say one solution is the right or wrong solution here. I'm trying to say that it's really case specific, and it depends about all of these things. What's the quality of the water that you're starting with? What sort of quality of water do you need to produce? How far do you need to transport that water? How distributed does that water need to be? How much can you rely on the existing infrastructure as opposed to having to produce new infrastructure? These are all the criteria that help us to understand what would you be looking for if you were trying to design and build a sustainable water supply. So the last bit I want to talk about really comes back to this climate change question and being resilient to extreme weather events. So we all know we went through this horrible period, first of all of drought from 2019 to 2017, right up to the end of 2019, and then the fires. What we started to see with the fires, apart from all of the very high profile destruction and loss of life and property and homes, water supplies, many water supplies also struggled during that period. And so we saw lots of impacts to water supply infrastructure, pipes, valves, pumps, but also the less obvious things like the electrical supply to a drinking water treatment plant. You can't operate your drinking water treatment plant if the power poles have all been burnt down and there's no power being supplied. So we saw real gaps in resilience of being able to continue to provide reliable, safe drinking water during these fires. That's something that we'll need to think more and more about if extreme weather events are going to be things that are going to become more frequent and more intense as we expect that they will. So I won't go into the details, but there were lots of water treatment plants around Australia that failed to the degree that a boiled water alert had to be called for the communities that were relying on drinking water from those plants. Some of them because the plants were actually damaged and impacted by fire. They lost power, they lost operations themselves. Some of them because the water treatment plant is actually the bottleneck in being able to supply water. They needed to keep providing water at a faster rate for firefighting to put out these fires than what the water treatment plants could treat that water at. So the water treatment plants were bypassed. And so where unsafe drinking water sources were used in those cases, then the water that was being produced was not sufficiently safe for consumption without having to boil that water first. So more and more, these are things that we will need to think about building in resilience to our drinking water supplies going forward. Even worse than the fires were when the floods came. After the fires, we had lots of impacts to raw water in river systems. Our catchments were burnt. A lot of the forest material ends up as ash on the ground on the catchments. When the big rainfall events came along, they washed that ash into waterways. So we end up with sediment, organic carbon, nutrients in our waterways, making the water very hard to treat in some cases, or impossible in some cases. Water treatment plants were not able to deal with it, and elevating the difficulties associated with producing safe drinking water. So we can look at what are some of the characteristics of schemes that prove to be vulnerable and schemes that prove to be more resilient under some of those extreme events. This one here, this is Brogo Dam on the Brogo River. It supplies drinking water to Bermagui down at Bega Valley Shire. This dam, so I'm only singling it out because one, it really did struggle. They were on a boil water alert for a long time because they weren't able to treat water because of a few factors. So one, they didn't really have a water filtration plant. It's just a chlorination system. So all of this ash and turbidity that ended up in the raw water in Brogo Dam, you can't really treat that just by adding chlorine. The chlorine just reacts with all of the organic matter and things that are there. So they couldn't produce clean water that way. Another feature of this is that this dam, this is a classic, it's an impoundment across what was previously a river, the Brogo River. So all of the water that is washed into this river comes down and is in your dam and is trapped here. What comes down the river is what you get, and there's no real way of dealing with that. There weren't alternative water supplies. To a degree there was, they trucked water down from another source. But it's not like there are alternative supplies that they could use to directly supply this city. So there was a single water source, really quite vulnerable in terms of all of this catchment being burnt and the impact that would have on water quality, and not really being able to do anything about it. So I compare that one to this off-river storage. This is Coffs Harbour here. Coffs Harbour has Karangi Dam. There were huge fires up at Dorrigo in the catchment of the Orara River, which is the river that runs along here that Coffs Harbour's drinking water comes from. Very serious fires, and further downstream as well around Nana Glen were devastating fires. So big impacts to water quality in this river. But the way this system works is that it's not a dam wall. It's not an impoundment across the river. They pump out of the river to this off-stream storage, which is not connected to the river. So they have the advantage that they turn on the pumps and they turn off the pumps. When the water quality in the river is good, you pump water out. When the water quality in the river is good, you stop pumping, and you have a nice storage here to be able to get through the periods of poor water quality. That's how off-stream storages tend to work, and it's a really big advantage in being able to manage the water quality that you're actually receiving relative to the water quality that's running down the river at the time. And we saw that for Shoalhaven. Shoalhaven had horrible fires up in the catchments around the Shoalhaven River and the Kangaroo River, both of which feed Dharawal Dam. Water is released from Dharawal Dam. It runs down the Shoalhaven River. Shoalhaven have a couple of off-stream storages, the most important one being at Bamarang, just on the southern side of the river there. They pump out of the river into this storage at Bamarang, which goes into the water treatment plant and supplies Nowra and other parts of the Shoalhaven for their drinking water. So even though there was really devastating impacts in the catchment here, these are all the fires, the area that was burnt out by fire. So huge impacts in the catchment, very poor water quality coming down the river. But Shoalhaven and Nowra weren't relying on it. They were relying on water from this off-stream storage, which you can see the fires got very close. But they were lucky that they weren't directly impacted. So lots of places ended up with water that looked like the water in Warragamba Dam at the time. It's chocolate milk, it's full of sediment. Sydney Water is still dealing with compromised water quality and the way they're having to deal with it at Prospect Water Filtration Plant. But Sydney has a couple of advantages when we start to think about resilience and how we can manage that water. So one of them is flexibility that comes with being able to take water from different levels within the reservoir. Often we might take water close to the surface because often that's the best quality water. But if we have a lot of sediment, or if we even something like an algal bloom might occur, we can go deeper down. Water New South Wales can go deeper down and deliver water from other levels. And by that way, being able to target the best quality water. That's something that you can't do on a small dam like Brogo Dam, but you have the opportunity on a big dam. So pointing it out because it's an example of flexibility, and it's that flexibility that gets you through these different times, being able to change the way that you do things, supply water in a different way. The other way Sydney got through those events was also because of flexibility. It's because of this big complex system. Most of our water is treated through the Prospect Water Filtration Plant. Here, most of that water traditionally comes from Warragamba Dam. But as many people here would know, we can also supply water from the southern dams up through the Upper Canal into Prospect Water Filtration Plant. We can take water from Prospect Reservoir itself for short periods of time. It's not a huge storage, but it can contribute to the water that's available. And we can also take the demand off that water by supplying water from the Seawater desalination plant, which is something that we continue to do for that purpose. So that's 15% of our water coming from here unaffected by what's going on with water quality impacts over here. So this tells us that if we want resilience, we want flexibility, this is another way of building it in, is being able to draw from different sources and choose the appropriate source at the appropriate time. So this is my one slide that talks about the southern catchments, just to make the point that they may be small. People talk about Warragamba Dam being 80% of our storage and 80% of our supply, but the southern catchments, the other storages, all play a really, really important role in terms of providing that resilience. When water quality is poor in Warragamba Dam, we absolutely need to be able to draw from other areas. And it applies in drought too. Even though they're a relatively small part of the storage, we do see periods where these dams will be holding more water. They receive more runoff than the Warragamba catchment can sometimes see during periods of drought. So we really need to think about the system as a whole and not think about, oh, that's just a little bit over there, because that little bit is often a very, very important component in terms of resilience. And I think it will be increasingly important as we deal with more and more of these effects. Skip a couple of slides because they're really just making the same point. So the last slide here is from the new Lower Hunter Water Security Plan. So the plan for Newcastle, what happens going into the future. Newcastle's a bit like Sydney. Here's the projected demand. Here's the available supply. There's already a big gap between what they think they can reliably supply from year to year and what the current demand is. So Newcastle, Lower Hunter need to think about addressing that. And they're thinking about addressing it through a number of different things, but all of these things are built into that decision-making. There is rainfall independent supply coming from things like new desalination plants that they're building. There's flexibility coming from being able to draw water in from alternative surface water storages that exist through building a new pipeline that will deliver water from another storage in. And there's more rainfall independent supply potentially in the future, some way out in the future, coming from purified recycled water, purifying that water and putting it back into the drinking water supply. So one, they're really benchmarking the rainfall independent supply and consciously trying to increase it. But two, they're also looking at diversity of sources, which supplies that flexibility going in. And those are big steps that have been taken on top of the more conventional approach, which is just thinking about sustainable yields from a particular dam and not thinking about how that might get you through extreme droughts or other types of extreme weather events. That's where I'll leave it, and happy to take any questions.
Thanks so much, Stu. There are lots of questions in the chat. If you've posed a question in the chat, I'm going to ask you to unmute and ask your question. Please just ask it directly. Don't waffle on. We've got 10 minutes, so it's going to be pretty quick fire, okay? But we've got a question from Gary about mining offsets, a question from Robin about the local sustainability of our water system. Mel wants to know about Lismore. Terry wants to know about research into recycled water. Ali's going to ask you about tailings dams, and Tom's got a question about sediment. So we'll take them in that order. Gary, if you want to unmute, if that's okay. And other people, if you can't unmute, can you just let me know in the chat and I'll ask your question for you. Over to you, Gary. Oh, you're unmuted, Gary. I'll unmute you. No. Your mouth is moving, Gary, but we can't hear your question.
I've got it. Righto. Yes, I just wanted to ask about where mining does take place in drinking water catchments, and we all know about losses through the mining operations, particularly where there's mine to surface breakages and other impacts on upland swamps, etc. What do you think are the best ways for mining companies to address that in a sustainable way? To replace the water that they have lost or used? They do say, the mining companies say that there will be offsets for water that is lost.
Yeah, absolutely. So we know that we know that there are losses, for example. I don't know that I can really give a great answer to what's the best way for them to address it. It might be something that we're talking to Ian or others about. To me, those are losses that are not easily recoverable because they're losses that end up at a low elevation below the catchment, and they are just going to be discharged at a lower level that won't be recaptured. So I don't have a good answer to how you offset those.
Robin, did you want to unmute and ask your question?
Sure. Hi, everybody. My question is about the Wollongong LGA in terms of our topography and I guess just regional context. Did you have any insights into what you thought might be a sustainable water supply system here? Yep.
So Wollongong has a pretty nice water supply, obviously, coming from Avon Dam. I guess if you look at resilience, it's like a few parts of the overall Sydney water supply, where it's a bit of an arm that sort of comes off the rest of the supply, where it is relatively highly reliant on a couple of key pieces of infrastructure. So in Wollongong, yeah, you don't have like that system that I put up for Sydney, where we can bring water in from different directions. In Wollongong, it's really the one storage, the one water filtration plant and distribution through that. However, that storage itself has some resilience built into it, in that Avon Dam it has some connectivity with, I think, Nepean Dam. Is that right, Dan? I think there's some connectivity, so that if water shortages, if the storage in Avon becomes relatively low, that water can be delivered from other parts of that system into that dam. But there are certainly bottlenecks in the system and opportunities for things to go wrong.
Cherry, did you want to jump in next? Mel's saying to put her question later. I don't know if you can unmute and ask your question, Cherry, or do you want me to ask it?
Okay, I just wonder, I was told by somebody from Sydney Water that they were doing research about using recycled water for the production of hopefully green hydrogen. Do you know anything about the amount of water that they would be considering using? And because I know at the moment the recycled water from this area, from the Illawarra, is used up in Sydney, I believe.
So a lot of the recycled water from the Illawarra, from Wollongong Sewage Treatment Plant, is actually used by BlueScope Steel for integrated steel makings, which is a really convenient use because they're quite close to each other. It produces a very high grade of recycled water, which they're able to deliver over into BlueScope. The question about green hydrogen, that is a very, very cutting edge question. I don't think anybody will have an answer for you on that one. That's something that the water industry as a whole has started looking around and asking those same sorts of questions. Can we take recycled water, for example, or other sources and use that for green hydrogen production? There's research beginning in that area, but nobody has made any real progress, I don't think. So therefore, I don't think there is a clear answer to that question, but you're right about the issue. We keep talking about we're going to have this hydrogen economy. We're going to make all of this hydrogen from energy somewhere, some sort of green hydrogen, and not enough people are asking the question that you're asking, which is where's all that water going to come from?
Cherry with a finger on the pulse.
Yeah.
And
Thank you.
we know that many coal mines use tailings dams to manage waste. And so Ali's asking, do we know much about how tailings dams are going in heavy rainfall events and floods?
Ian, help me. That's an Ian Wright question.
Is Ian still on the line? He was here for a bit. He might have
gone.
You can pass on.
We have had some disasters with those. There's one, we've had molybdenum spills and arsenic spills. It's about whether they fail. It's not so much, you can always design the dam to be perfect, but they can still leak or fail. So and obviously in the long term, it's in 50, 70 years time, what happens to that tailings dam, that waste? So the sort of best practice is a zero liquid discharge and a resource recovery approach, but that's not normal practice. Normal practice is just to leave it in a tailings dam and hope it never fails. But we've had some people unable to use water in places in Australia and also in China recently from tailings dams failing, and also fish kills and things downstream from the tailings dams failing. So it does happen occasionally.
Which speaks to Cherry's follow-up question in the chat here, where she's asking who's responsible for the water that drains out of mines after they're long gone, and how on earth do you offset a swamp? Sorry, Cherry, I'm just asking a question in the interest of time. But I don't know if you have any perspective on that, Stu, or Daniel.
Yeah, well, how on earth do you offset a swamp is the million-dollar question, isn't it? And I think that question about who's responsible applies in so many areas. There's the tailings dams, but there's all the mining itself. What is going to happen over the long term when mining in Sydney's drinking water catchment and elsewhere pack up and move away? How are we going to deal with problems that might become evident further decades down the track? And I think there's evidence that we're leaving ourselves vulnerable there.
Tom, your question's in the chat. Would you like to ask it?
Yeah, hi Stu. So we're all familiar with the iron leaching out of the longwall damage into those western catchment areas. Is that likely to affect water quality in the long run as it fills up behind the dam wall? You were talking about variable offtake. Is that something that might be a future problem?
Yeah, so you're talking about Warragamba, and I think so. I think that all of those things you can deal with water quality problems by treating them, and that's ultimately what will probably happen. That we'll have to invest more money and more energy in treating water because you've got more contaminants that need to be removed to meet water quality guidelines and water quality expectations. So yeah, I think that some of that iron is soluble and be pumped out through the water treatment process and removed that way. But a lot of it, and I know Ian's published work on this, a lot of it is ends up being insoluble and ends up in the sediment, and that's not going anywhere. So yeah, that will accumulate, and you will end up with metal contaminated sediment in the bottom of those bottom of those dams pretty much forever until we have some technical solution for dealing with it, but we're not even close to being able to do that.
And lucky last, Mel would like to ask you if you could tell us about Lismore's supply. Is it back up, and how things went with their supply during the floods, and thoughts on changes needed to their effluent treatment post-flood?
Dan probably knows more about that. My understanding is that they did have some serious difficulties. Wastewater treatment plants often really struggle the most because wastewater treatment plants are down low in the catchment and do get flooded out and damaged, and can take a long time to get back up and running again. I'm not aware that there is a drinking water supply problem in Lismore. Do you know, Dan? I think
yeah, there were about a dozen boil water notices around the east coast from parts of Victoria, a lot in New South Wales and Queensland. Lismore managed okay on that front, but there were others just north of Lismore. They had boil waters on, and south. It was more in Lismore. It was more the sewage overflows from the storm impacting irrigation areas for crops, causing problems with crops, and also closing of beaches. Beaches had to be closed because they're still closed now because of all that sewage pollution.
So the upstream thing. So one of the big suppliers in Lismore is Rocky Creek Dam, which is on the same part of the same catchment and waterway that led to these floods, but it's very high in the catchment, and therefore you have less water that high in the dam. And I think that dam is still in reasonable condition, and the water filtration plant that supplies water from it is operating fine too. But as Dan says, it's the wastewater treatment plants, it's the beaches, it's all of the things that are down low in the catchment that tend to get knocked out the most. And we saw that in Brisbane as well during the Brisbane floods, although the water treatment plants struggled in that case as well. But there've been over the last few floods, there've been some significant impacts to wastewater treatment plants, and a lot of them take months to get them up and running again.
Yeah, and the Sydney and Brisbane treatment plants have been on public water restrictions this year. Brisbane's on again last weekend, or this weekend just gone, because they couldn't cope with all the dirty water. They just had to slow down their rate of production of water because they couldn't cope with it.
Yeah.
Well, that was a very amazing 10 minutes of rapid fire questions. Thank you so much, both Dan and Stu, for responding to those questions. And thanks so much for your presentation, Stu. People are going off in the chat saying how wonderful and informative that presentation was. And it really speaks to all of the presentations we've had in this autumn series of Power Talks. We have had such incredible independent researchers and academics come and present for us. We've had Tom and Ian, we've had Tanya Mason, and I really want to thank all of you and all of them for generously contributing their time and sharing their knowledge with us. And also to recognise the wisdom in the room. Power brings together an incredible community of very knowledgeable people, and people who are on a journey together to learning more about all of these issues that affect us all. So thank you so much to all of you for attending. There's a vote for Dan Deere to join us in the next series of Power Talks, perhaps from Ian Wright. And that's also a request to all of you. If you've got suggestions, if you'd like to see someone be invited to come and present for us, drop Power a line, and perhaps you can help me and Claire to organise another series of talks. For now, we're going to take a little break, but I want to also thank Claire and Andy and Kay and Ali and a lot of other people around Power who've supported this talk series to happen. And we're going to take a little break, but we may reinvigorate the talk series again, perhaps in winter or spring, and we'd love your contributions towards that. Don't forget to register, sign up, follow the things that are coming up. It's going to be a big few weeks of activity down here to protect our water catchment. And so I look forward to seeing you at some of those events. Night,
Brilliant.
everyone.
Thanks for the invitation.